Welcome. This screencast is going to be about the difference between close-up and distant vision and the changes that your eye has to make so that you can focus on things that are close up. We are going to start off by talking about lens shape and a little bit about the light rays for distance versus close-up objects, and then we're going to put it all together. So starting with lens shape, you've got your lens, which is connected to the ciliary muscle here by these suspensory ligaments. So when the ciliary muscle relaxes, this means that all of the fibers that make it up get longer. When the fibers of a circular muscle get longer, then the inner circumference of that circle becomes larger. This puts tension on the suspensory ligaments that attach the lens to the ciliary muscle and pulls the lens out in all directions. When that happens, it gets pulled out wider and it becomes thinner. So you can kind of think of it almost like a partially inflated football that you're pulling on either end of, or perhaps a water balloon that would normally want to be big and round, but when you pull on either end, it becomes longer and thinner. So, normal circumstances, ciliary muscle relaxes. That puts tension on the suspensory ligaments and pulls the lens flat. When your ciliary muscle contracts, then its inner circumference becomes smaller. This reduces the tension on the suspensory ligaments and also therefore reduces the tension that's being applied to the lens. Then the lens can assume its normal, wider, more sort of blobby shape. So again, contracting the ciliary muscle actually releases the tension on the suspensory ligaments, and this allows the lens to bulge more or to become more round, as a water balloon would if you just left it sitting on the table. So now for the light rays. Um, what you have to remember is that your pupil is a really, really small object. So for an object several feet away from your pupil, divergent light rays from that object that still hit your pupil are practically parallel, which means they're not diverging much at all. So this is what light rays coming from a point source of a distant object would look like. They're practically parallel when they hit your eye, which means they don't need to be bent a lot in order to get them to hit the same point on your retina. So you need to remember that they originally came from the same point on the object. They just look like this when they hit your eye. So if they went straight, it would look like this red line here. So this angle right here between this blue line and this red line represents how much your lens has to refract or bend those two light rays to get them to meet again at the same point on the retina. So here we have kind of a faraway object and a definitely very close-up object, and you can see that the light rays from the closer object are much more divergent than the light rays from the further away object. So up here you have to bend about this much to get the light rays to meet again, and here you have to bend that much. So the angle of refraction, the degrees through which your lens has to bend the light, is much greater for close-up objects than it is for distant objects. So now we put it all together with the slides that you've already seen in lecture. For distant vision, the light rays are practically parallel, which for us means they don't have to be bent very much. If they don't have to be bent very much, then the lens can be flat. The ciliary muscle will relax, it'll get wider, that'll put tension on the suspensory ligaments, or what is called here the ciliary zonule, that will pull on the perimeter of the lens, widening it and flattening it out, or I should say flattening it out. So that is distant vision. And then for close-up vision, three things have to happen so that your eyes can focus on an object that's close up. It's accommodation, constriction, and convergence. The first one, accommodation, is the changing of the shape of the lens. So now you have an object that is very close in front of you. The light rays are much more divergent, and they need to be refracted more to get them to refocus on the same point on your retina. Now your ciliary muscle has to contract. It's going to reduce the circumference of its donut hole, the circle in the middle of it. That eases the tension on the suspensory ligaments. And if you look at them, they're actually little squiggly lines now to show that the tension is now slack. This allows the lens to bulge, so it gets thicker here, and a thicker lens is going to bend the light more, just like a thicker magnifying glass is going to magnify an image more. So that's the first part, accommodation. I'm going to skip over this. And then the second, or the next two parts, are constriction and convergence. And as it just says here, constriction is when your pupils constrict so that you're only getting light from whatever is in the center of your field of view, as opposed to the periphery, which is just going to decrease the acuity or the sharpness of the image that you see. And then convergence is medial rotation of the eyeballs, or you just go slightly cross-eyed. So that's it. Distance versus close-up vision, accommodation, constriction, and convergence. Hope you enjoyed it. Thanks.